Indiana University East Chemistry C106, Conjugate Acids and Bases. Thus far we have stated that in Bronsted-Lowry theory, an acid is a proton donor while a base is a proton acceptor. We have further discussed how acids must react with bases in such reactions. And we have stated, therefore, that we must have, therefore, for example, an acid here and a base. Now here we have nitrous acid reacting with water, which is what happens when you dissolve in water. And what happens is that, because this is a weak acid, as we'll discuss later, we have an equilibrium sign here, and the acid loses a proton to form the nitrite ion here, while the base here, the water actually gains a proton here to form an acid, H3O+. Now, let's look at this. We always have one acid which loses a proton, while we always have a base that gains a proton. The acid losing a proton results in the production of the conjugate base of the acid. Remember, it's losing one H+, not two H+, not three H+, and not just an H. Your charge must change as well as the number of protons. Similarly, we have our base here. Here, what is our base? And we add H+, one H, and a plus here to form the conjugate acid of water. Let's look at a couple more examples. Here we have acetic acid reacting with water. Okay, and this is a weak acid, so again we have double harpoons. And here our acetic acid is going to lose an H+. With carboxylic acids, COOH, you need to remember that you always lose this H here. You don't lose the H's from here, because these H's are bonded to C and it's not actually likely to break off. And therefore, as a result, we form CH3COO. We lose this last H here, and we decrease the charge by 1, so we get CH3COO-. So this is acetic acid, this is the acetate ion, and this is therefore the conjugate base of the acid in this reaction. And the other thing we form is that this H+ goes on to the water. So water, which acts as a base here, is going to gain a proton to form H3O+ AQ, which is the hydronium ion, and that is the conjugate acid of H2O. Let's look at this one now. We have fluoride ions dissolved in water, and now the fluoride gains a proton from H2O to form HF. So here the fluoride is acting as a base, and this is my conjugate acid. This is the conjugate acid for F-. Now in this case, where's this H coming from? The H actually comes from the water. So we form OH- in this reaction. The water loses a proton, so it is acting as an acid. And the conjugate base of water is the hydroxide ion. We have shown, incidentally, that water can act as either an acid or a base. and therefore refer to it as an amphoteric substance.